Okay, so you do need to use transformations a little bit really in curve sketching. So I'll go over using transformations to sketch some modulus functions. So you know y equals modulus of x. That's our sort of most basic sketch, like so. So sort of building up some ideas from there. If you wanted instead to sketch y equals minus the modulus of x, if modulus of x is f of x, then minus modulus of x is minus f of x. So that's a reflection in the x-axis. So to sketch minus modulus of x, you need to pick this up, reflect it in the x-axis. In terms of equations of line segments, you're going to need these when we do some equation solving. This one here becomes minus what it was before. So this will be y equals minus x. And minus negative x gives you y equals x. Right, next one. If we've got y equals 3 lots of the modulus of x, that's like having y equals 3 f of x. So that's a stretch by its scale factor 3 in the y-axis. And so the curve is going to be looking like that. And equations y equals 3x, y equals minus 3x. There and there. If you think about it, that's going to look the same actually, but this is a one-off as that, but they're not always interchangeable like that. Okay, so if instead I have y equals 3 minus modulus of x, that's the same as having minus modulus of x plus 3. So you can reflect y equals modulus of x to get minus modulus of x, and then you can add 3, which moves you up by 3. You need to follow your order of operations here. So you'd multiply by minus 1 and then add 3. So you reflect and then you move up. So this goes up by 3. You could work out the equations of the line segments, but that one's y equals minus x, and then it gets moved up by 3. I will do one more example after this as well. So that's y equals minus x plus 3, and this one is y equals x plus 3. So you can build up your sketching. I'll just do one more. Oh, that's what I was going to say. Your x-axis intercepts are where y is equal to 0. So to find those, I'll find a different colour. If y equals 0, then minus modulus of x plus 3 equals 0. Minus, well, if I just add mod x to both sides, then you get modulus of x equals 3, and so x will equal plus or minus 3. So you can still get to your x and y axis intercepts by letting x equal 0 and y equals 0. Obviously it's quite obvious on that one. Right, one more. So on my previous video, just checking that's right, we sketched y equals modulus 3x minus 2. So I won't go back over that. Hopefully it'll be okay with those. And that goes 3, 2, and 2/3 on the x-axis. Like so. And then equations of line segments. Y equals 3x, take 2. And this side we've got y equals minus 3x, take 2. What I actually want to sketch now is y equals minus the modulus of 3x minus 2 plus 6. If you didn't have this minus here, you could just move this up by 6. So if that wasn't there, you'd just be moving up by 6. The minus reflection, the x-axis. So that takes me down from 2/3 minus 2. Same shape. And then equations of line segments. This one would be minus. Let's make it clear what we're doing. This one will be minus what it was before. So it's minus brackets 3x take 2. And this side here will be minus what it was before. So obviously when you times that by minus 1 you just get positive. So this one here is y equals 3x, what a funny angle now, minus 2 for the equation of that line segment. And then adding 6 moves you up by 6. I'm not quite sure I've changed to blue. So this y-axis intercept is going to go from minus 2 up to 4. The steepness is still going to be the same. If you wanted to put your x-axis intercepts on next, then we're letting y equal 0. So when y is equal to 0, to find where it's crossing the x-axis, modulus of 3x minus 2 will equal 6. So either 3x minus 2 is 6 or minus 3x minus 2 is 6, i.e. 3x minus 2 is minus 6, and then I can add 2 and divide by 3. Adds 2 gives me minus 4 over 3. So x-axis intercepts minus 4 over 3 and 8 over 3, so something like that. Shape's the same, so this, where you get this maximum point here, that will still be where x is equal to 2/3, so it'd be half the way between there and there. We don't need to mark it on particularly as coordinates. That one might not look quite as steep as the other one, but that's fine. So I'm going up to there-ish. Sorry, it's not perfect. And then down through there. It's a nice straight line. Equations of line segments. So that one there is y equals, I've added 6, so it's minus 3x minus 2, add 6. And then this one here is y equals 3x minus 2, add 6. You could tidy this up now, so this is 3x plus 4, So we're getting that y-axis intercept when x is 0, at 4 on that one. And this one is minus 3x plus 8. So, yeah, we'll come back to that next video. So you don't have to put on the equations of the line segments, but I possibly would for now, so that you've kind of got into the habit of what to do. But transformations and curve sketching is very useful.